Hi, so this is a quick video about a workflow called real-time collaboration with Zimmer and Peacock. So at Zimmer and Peacock, we really believe that actually one of the best people to collect sort of raw data is actually often the collaborator, the person outside of Zimmer and Peacock. But in order to do that, we need a couple of things. So we probably need you to have an instrument called a potentiostat. So we have a range of these kind of instruments. Now the potentiostat will allow you to collect the raw data of the sensor. So what I mean by raw data is current versus voltage, or current versus time, or voltage versus time, but the real raw data of the sensor. Now the other part that you'll actually need is the, let's say, the sensor or the screen printed electrode itself. I know it's kind of slightly obvious, but effectively you're going to need something like this, maybe from Zimmer and Peacock. Maybe it's functionalized to be a sensor, or maybe it's just the screen printed electrode itself. So you're going to, effectively, we're talking about, you're going to need some hardware. You're going to need a scientific instrument, which ZP has, and you're going to need some screen printed electrodes or some biosensors. Now, the other thing, the reason we think that outside collaborators are one of the best people to kind of work with when doing the biosensing is because you actually have, I mean, here I've just got some spices. We do a lot of work in the food industry, but I'm kind of saying that, as an outside collaborator, you probably have one of the best accesses to samples, and you also have a great insight into samples that, maybe at Zimmer Peacock we don't have that insight, but you work with this kind of sample day in, day out. And you also understand the kind of workflow that's rational, that if there's going to be a methodology in this overall sensing system, then you're going to understand that methodology. Now, what we would need in a collaboration is for you to record raw data. So here I'm just showing cyclovoltammetry. So we need you to be able to record the raw data, and that's why I'm saying you need the potentiostat, and you're going to need the sensors, which we might have manufactured for you, or you might just be using screen printed electrodes, but you're going to have to grab that raw data. And then the other thing that would be really useful is if you can test samples on the electrochemical instrument, and also test samples on the, I want to say, on the golden standard. What's the way that you would normally test that sample? What's the laboratory or the analytical laboratory or the clinical laboratory way of measuring that sample? Because what we're trying to do later on in the workflow is correlate the golden standard way of measuring the sample, and we're going to try and correlate it with the electrochemical data. So it's great that as our collaborator, you are able to gather basically two data streams. One of them is the electrochemical data stream, and the other one is to be able to then also gather on the same sample what the concentration is by the golden standard. Now, if there's not a golden standard, it can also be answered by, for example, the concentration because you made up the sample yourself. If you put, if you know that the concentration is 1 millimolar because you made up the solution, then that is the answer. But in samples that are truly from, like, say, nature, or natural, then you won't know the concentration because you didn't make up the sample. You're going to have to measure it on a third party. So it's good. So what we're saying is we would like you to gather electrochemical data, and we would like you to be able to tell us what the concentration is in there. Because then what can happen is you can upload the data to the Julie database, and we can start doing analytics on your data. So you would upload your raw data, and we will, and we will do the analytics on it. And we also want you to put the metadata up there, so we can definitely figure out that. When I say metadata, sort of sample description, known concentration, so that we, so that we can sort of tag the data accordingly and start working on the electrochemical signal. Because what we're saying is, the thing that makes ZP probably quite useful for this is we have a very good data sciences group, so we can look at the overall signal that you send us, and we're going to know the concentration, and so we can start working out the best correlation between the known concentration and the electrochemical signal, because we don't have to just look at the signal in a fairly naive way. You know, we can look at several points in the signal and say, you know, does the sum or the difference of several points within the data actually constitute the overall electrochemical sensor? So we can end up doing kind of correlations between known concentration and electrochemical signal, and then come up with that sort of best fit. So there's kind of, you know, there's you at the front end gathering all the data. There's you uploading the data along with the tags, which is sample description and known concentration. And then it's us looking at that raw electrochemical data and knowing the known concentration because you told us, and then coming up with that kind of correlation between known concentration signal, which will basically allow us to come up with a algorithm where we can calculate concentration from signal, and then we can then use that algorithm to get back into an app so that the app is kind of more accurate. So I think it's worth saying that we do quite like the idea of this collaborative workflow at Zimmer and Peacock. I think it's worth saying that we do have quite a nice database for doing this kind of collaboration with. So I'll just go there now. So I'll just kind of bring it in. So this is the database. If I just give you a quick demonstration of it, it allows you to upload raw data. So you can click here and then upload raw data, and it allows you to kind of obviously put the date in, the operator, description, you know, some sort of, you know, the purposes and stuff. So we can add all of that in there. And then when we've got it all in there, what it allows us to do then is here that we have a set of, you know, electrochemical data. We've done some normalization of the data in terms of making the baseline all 0, because what happens here is when this data set, there's a 0 millimolar, and then we do a spike and we go up to maybe something like 10, and the signal changes accordingly. So we are able to kind of take all the data and do some fairly rapid analysis on it, and, you know, we can quite rapidly calculate, you know, limit of blank, limit of detection, limit of quantification, what's our kind of standard deviation, you know, so we can do quite good batch analysis on data. So I'll just go in here and, for example, you know, if in fact, if at time 1500 the concentration was 0, and at 1750 the concentration was 10, for example, done. Then what it's doing is, it's basically taking all the data at one time point and comparing it to all the data at another time point, and then it allows us to calculate the gradient and the intercept for that entire data set. So we can do quite a bit of data analysis in this tool, and then we can also do this kind of optimization. Let me just drag that back. You know, I sort of describe this optimization cycle where we actually want to figure out the best way of extracting your signal. So we can actually do that as well once the data is in that cloud system as well. So I'm going to sort of do a quick summary now then. So at Zimmer Peacock, we like to be collaborative. We do actually agree that the external collaborator, is possibly one of the best people to collect this kind of data. You sort of understand the samples the best, and you probably have access to the samples, which is, you know, even better. And you probably even understand how you do the sample analysis today. So you've got all those kind of elements in place, and what Zimmer Peacock would do is kind of guide give you the, get you access to Julia so the data can go up there. And then effectively, as you do work in the lab and you upload the data, we can basically start the algorithm development almost as you're in the lab collecting data, and we're online analyzing your data. And then we can kind of have an iterative cycle where we're kind of able to feedback and show you how this is working or not working. So that's a summary. And if you have any questions, please contact us at Zimmer & Peacock. Okay, thanks very much.